Any question about the last lecture? You missed the last lecture, why? Tired. And you, Abdullah? Same. Tired. And you? Tired. You? You are not here in Jeddah. You are in Taif. Nice place. Because I was surprised, the whole group is absent. Not one guy, no problem. 1, 2, 3, 4, 5. See, all. So we covered about the pattern in the last lecture. Mr. Khalid, what is pattern? Yes, Tamim? Darvesh was also absent. Nafi Majood in the last. Why? Car accident. Sierra problem. Abdul Rahman. Huh? With Darvesh. After this lecture, I will discuss something. Yeah. Anyway, yes, Mahmood, pattern. Yes, Mr. Riyad.
Connective problem or something to design.
It's a structure or template designed to provide solution of a specific problem. As we already discussed, it has three things: context, problem, and the solution. Mr. Khalid, what is context? You are looking in the slide. It's not written. Mr. Tamim? Nasir? Mr. Muhammad? Yeah, Mr. Darvesh? I think it's third time or fourth time I'm repeating the same thing. I think after every lecture you format the hard disk. Not every semester. At the end of semester. Yes. Mr. Muhammad. Abdullah.
What is the problem?
This is context. What is the problem? What is the problem? Yes. Sure. Very good. Abdul Rahman? Mr. Mahmood? Mr. Abdullah? Then Mr. Haitam? The environment in which your pattern is going to work, and what are the constraints regarding the integration. Actually, you don't take notes. This is the problem. Or even you don't take notes, you never study them. And we have a problem for which we are writing or we are using the pattern, and there is a solution. The context Here is the description what you are trying to read in the previous slide for the context. To understand an environment in which problem resides and what solution might be appropriate within that environment and what are the constraints regarding that, the requirements for the problem and the solution. This is, I already covered about the pattern. We have problem, we have context, forces, solution, intent, collaboration, consequences, and the known users and what are the related patterns. These are the characteristics. It solves a problem. It is a proven concept, already practiced. Don't try to reinvent the wheel. Because already pattern is there, don't try to develop your own pattern. Yes, pattern is there, customize it as per your requirement. Yes. The generic pattern is there, customize it as per your requirement. And the solution is not obvious, it's generic, so you have to describe the generic customized solution. And there is a relationship between the patterns. And pattern has a customization role. Humans are there to customize them. So we begin with the requirements and then we try to identify the suitable patterns. This shown, the whatever is written there in this diagram, I try to explain you. The requirement model is there and then we have the design concept and then we try to select the suitable pattern. And we will continue this loop until we find the suitable pattern. And you have to think about the generic picture, the complete picture, complete understanding of the system. And then examine the picture, mean analyze the problem, what is the problem for which you need the pattern. And you begin your design with the picture to establish a context and the skeleton. Work inward from the context towards the problem and then the solution. Repeat the step if you did not find the suitable solution. Again, try to understand the system and then try to identify the suitable pattern. But when you are a beginner, you need more time. But when you are a professional, you are already working in that environment, then it's very fast process. Like the Google, you will do like this. So we have the task. We already discussed in the previous lectures. Try to determine the suitable language and we have beginning a broad pattern using the collaboration and repeat the steps number 2 through 5. Here we discuss about the pattern repository and then we have the generative patterns. What are the main types of patterns? We have 3 types. We have architectural, we have design and we have the idiom. Mr. Khalid, what is the architectural pattern? Yes, Mr. Abdullah, you are asking to another Abdullah? No. Yes. Architectural pattern. Darvesh? UML is a modeling language, my friend. UML is not a pattern. The use case, yes, class diagram, sequence diagram, or data flow diagram, DFDs, ERD, these all are examples of architectural pattern. And then you have the design, the 23 patterns, which is the core of this course. Yes, the gang of 4. And then you have idiom pattern. Mr. Muhammad, Mr. Taween, Mr. Yazid. Algorithm designing techniques. Anyone? What are those techniques? pseudocode, flowchart, decision table, decision tree, NS diagram. There are 5 techniques. Flowchart is the most widely practiced because it's easy, graphical way and easy to understand, and abstract design as well. It's an abstract design as well. So I show you, we have different type of architectures. We have building architecture, we have modeling a house, the models, we have Egyptian pyramids, the classical architecture, and this is the modern architecture when you use ceramics, metals with the symmetry. This is the different ages in the civil architecture. Why I am showing you all this? Because most of the concepts we took from the civil engineering in this field. The component concept even we took from there. The pattern concept we took from there. Like the block structure. If you see now the construction, they use pattern. Like for a room, they already have a pattern. They put the pattern, then plug the walls from one room to another room and so on. And then the block structure, the blocks, it's also pattern. You can see the blocks. These are the patterns, standard. It's not like the sizes are different. They have exactly the same size. So we have different civil architecture, community, commerce, industry, and the layer regarding the sports, theatres, cinemas, museum. The forces in civil architecture, we have compression and we have tension. Just to understand, yes. Because after this, I am going towards the software. That we have compression and we have the load, the tension. The main layers, this is just for your understanding. We have 5 layers. We have 1, 2, 3, 4, 5. 5 layers are there. And this is the inside stuff for which you are doing all this. Ceilings. These are different ceilings to protect water or the sunlight, the heat, the protections. Now we come towards the dimensions of complexity. We have different type of complexity from high to low technically, and from management point of view, low to high. Like the projects in terms of high technical complexity, the compiler, automated software for automated coding, automated testing, automated designing, the case tools. I already covered case tools with you in the 251. Have you covered? What case stands for? Case. Mr. Khalid. No problem. We cover 250. Yes? Huh? You didn't remember what did you cover in 250? I think after this semester you say I did not remember what I covered in 252. Yeah. He's pretty sure about it. Yes. Case. What case stands for?
Case? Case for the
Computer aided software engineering tools. How many types of case tools we have? How many types of case tools we have? Types of case tools. We have 3 types. We have uppercase, We have lower case and we have cross life cycle case tool. Upper, lower and cross life cycle. Upper case tools. The tools we use up to the design phase of SDLC. For example, any tool that we use up to the design phase. Khalid? Any tool we use up to the design phase of SDLC. During planning, during analysis, during design, any tool? Mr. Abdullah? There's another Abdullah? Nasir? We don't have any tool up to the design phase. We don't use. Any tool that we use up to the design phase. Microsoft Visio. Visio. Have you used Visio? Yes. E or Win. These are examples of uppercase tools. Visio, have you used? Visio, MS Visio, have you used? Mr. Darvesh, have you used? Yes. Or you are just saying because they are saying yes? I am with you wherever you go. Lowercase tool that we use during implementation and post implementation. Lowercase tools that we use during implementation and post implementation. For example, time up. Why your system is on? Make it shut down. Yes. Any tool that we use during implementation and post implementation. UML is used during implementation. You don't know, then who knows? Allah. You already covered so many courses, my friend. Yes. 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 Any tool that we use during implementation, post implementation. Do you want? I will. Any tool? Yes. Programming tools. Programming tools we use during the implementation. C, C++, Java, .NET, PHP. Testing tools. Testing tools that we use during the implementation. After coding, we test it. We have testing tools. Any example of testing tool? Any example of testing tool? UML? G-Unit. J-Unit. I thought there is a new tool. J-Unit is there. Have you used J-Unit? You know Java? J-Unit.
J-Unit?
Yes. J for jug. J-Unit. Have you used J-Unit? Have you used? You just heard about it. You never use it. No need to use it. We have load runner. Load runner.
Load runner.
Load runner is a testing tool. Test director. Test director is there. Load runner is there. N unit is there. J unit is there. J blanket is there. There are so many testing tools. N cover, J unit, fitness. These all are testing tools. And then you have cross life cycle case tools, the third type that we use throughout the SDLC. For example, any tool that we use throughout the SDLC. Any tool that we use throughout SDLC.